Dear friends, myself, Mr. Sirsagar sir, presently working as an assistant professor in chemistry, Rayat Shikshan Sanstha's Dada Patil Mahavidyalaya Karjat, Dist Ahmednagar, affiliated to Savitribai Phule Pune University, Pune. Today I will discuss crystal structure from paper CH341 Physical Chemistry, same for T.Y.B.Sc class. So let us see outline of the topic. Point number 1, matter. Second, classification of matter. Third, types of solid. 4, crystallization process. 5, fusion process. 6, crystallography. 7, laws of crystallography. A, Steno's law of constancy of interfacial angle. B, laws of rational indices. C, laws of symmetry. First of all, my question is that what is matter? Matter is anything which has mass and occupies space. We can classify matter into 3 categories based upon physical properties as solid, liquid and gas. In case of solid, atoms, ions and molecules are arranged in an orderly manner. It has a definite geometrical shape, definite value. But in case of liquids, molecules are randomly oriented. Therefore, it has no definite shape. So it has shape of container and a definite value. But in case of gases are too lighter, too randomly oriented due to it has neither value nor mass. So solid has fixed shape, fixed value, not compressible, not flows. Liquid has indefinite shape, fixed value, no compressible, but it will flows. Gas has neither value nor shape, compressible and fluid. Therefore, we will consider solids, and solid can be further classified into 2 categories: crystalline solid and amorphous solid. So let us see crystalline solid. In a crystalline solid, atoms, ions and molecules are arranged in a randomly order, and therefore it has a definite geometrical shape. It is also called as a true solid, and it has definite heat of fusion. Amount of heat is required to melt a solid into liquid, so that heat is called as heat of fusion. And crystalline solid has definite heat of fusion. It has sharp melting point, so crystalline solids melt sharply, and crystalline solid has properties are different in different direction. Such a properties are called as anisotropic properties. So examples of crystalline solids are salt, diamond, sugar. So second type is amorphous solid. So in amorphous solid, atoms, ions and molecules are arranged randomly. Therefore, it has no definite geometrical shape. It melts over a wide range. It has no definite heat of fusion. Its properties are same in all directions. Such a properties are called as isotropic, and amorphous solids are called as pseudo solid, or this is also called as supercooled liquids, and properties are same in all directions. Such a properties are called as isotropic in nature, and therefore examples are plastic, glass, charcoal. So next point is crystallization and fusion. Crystallization is formation of ice and fusion is melting of ice. In crystallization process, we have to take pure liquid that is cooled under pressure, and due to that its average transitional energy decreases, temperature decreases, and attractive influence becomes more, and due to that atoms, ions and molecules arrange in a regular manner, and there is formation of solid at its freezing point. But in case of fusion, we have to take pure solid, heat that solid at high temperature at a constant pressure, and due to that its vibrational energy increases, temperature increases, and solid is converted into liquid. Such a point is called as melting point. Crystallization temperature is the temperature at which liquid is converted into solid, and fusion temperature is the temperature at which solid is converted into liquid. At freezing point, attractive force becomes more dominant over transitional energy. At fusion point, attractive force becomes less dominant over transitional energy. Crystallization is exothermic process, heat is evolved, and fusion is endothermic process, heat is absorbed. Say that heat of crystallization is amount of heat is required to convert 1 mole of pure liquid into 1 mole of pure solid. Heat of fusion is amount of heat is required to convert 1 mole of pure solid into 1 mole of pure liquid. Heat of crystallization and fusion both are same. Its magnitude is same. Magnitude of heat of crystallization, magnitude of heat of fusion, same, but its sign is different because crystallization and fusion, these are opposite processes. Crystallography is a branch of science which deal with the study of crystal with respect to geometry, properties, and crystal structure. Geometric crystallography is a branch of crystallography which deal with the study of arrangement of planes and geometric shape of crystals. Crystallography based upon three fundamental laws: Steno's law of constants of interfacial angle, Hev's law of rational indices, law of symmetry. So we'll discuss one by one. Law of constancy of interfacial angle, proposed by Steno Nicholas in 1716. Interfacial angle is an angle between the two faces of the same substance, measured with the help of goniometer instrument. First of all, Steno Nicholas measured the interfacial angle of a quartz, and he made observation that interfacial angle is independent upon growth rate of a crystal. And he wrote a statement: interfacial angle of same substance is measured at same temperature, is a constant and independent upon. So angle between the two faces of the same substance. So this angle is called as interfacial angle. This angle is also called as interfacial angle. This angle is also called as interfacial angle. So interfacial angle of the sugar is 90. If the crystal is bigger, if the crystal is smaller, if the crystal is still medium sized. So next example is interfacial angle of graphite is 120. So interfacial angle is angle between the two faces of the same substance called interfacial angle, measured with the help of goniometer, and graphite has 120. If the crystal is bigger in size, then for medium sized it is also 120. For smaller size it is also 120 degree. So laws of symmetry. Statement: all crystals of the same substance possesses same element of symmetry. In a crystal, element of symmetry can be studied with respect to point, plane, or line. Cube has 23 elements of symmetries, 9 plane of symmetry, 13 axis of symmetry, and 1 center of symmetry. So first one is, we will consider 9 plane of symmetries. First one, cubical plane of symmetry. A cubical plane is drawn in the cube, which divide cube into two equal parts. One is mirror image of another. So cube has 3 directions. Therefore, cube has 3 plane of symmetry. So cubical plane of symmetries are 3. Second one, rectangular plane of symmetries. A rectangular plane is drawn in the middle of the crystal, which divide crystal into 2 equal parts. One is mirror image of another. So rectangular plane is drawn in the crystal, which divide crystal into 2 equal parts. One is mirror image of another. So this one is also a rectangular plane of symmetry. Therefore, plane has 3 rectangular symmetries. Then after that, diagonal plane of the symmetry. Diagonal plane is placed on the diagonal face of the crystal, and crystal has 3 directions. Therefore, it has 3 diagonal plane of symmetry. So total 9 plane of symmetry. So 3 rectangular plane of symmetry, 3 cubical plane of symmetry, and 3 diagonal plane of symmetry. Total 9 plane of symmetry. Axis of symmetry. An imaginary line is passed through the crystal, which divide crystal into 2 equal parts. Around which crystal is rotated through the 360, which gives an imaginary line is passed through the crystal. So n-fold axis around which crystal is rotated through the 360, rotation which gives 360 same appearance more than 1. If equivalent configuration occurs after n-fold axis of symmetry, 120. If the angle of rotation is the axis of rotation are 2-fold axis of rotation. If equivalent configuration occurs after 180, 120, 90, n is equal to rotations are 2-fold axis of rotation. 3-fold axis of rotation, 180 degree centigrade symmetry. 180 degree. If n is equal to 2, then and crystal is rotated through the 180 degree centigrade. 180 degree. If n is equal to 180, the crystal is rotated through the 180 degree. It achieves same appearance twice. Such axis is called as dyad axis, and there are 6 dyad axes in a cube. If n is equal to 3, the crystal has to be rotated through the angle 120. It achieves same appearance thrice. So axis is called as triad axis, and there are 4 triad axes for a cube. If n is equal to 4, so it crystal is rotated through the 90-degree. It achieves same appearance 4 times. Axis is called as tetrad axis. There are 3 tetrad axes. So total 13 axes of symmetries a cube has. Center of symmetry. An imaginary point is drawn in the crystal. An imaginary point is drawn in the crystal through which we draw the line which divide crystal into 2 equal parts. One is mirror image of another. So we can draw only one point in the crystal. So it has one plane of symmetry. So it has one center of symmetry. So total element of symmetries are one center of symmetry, 9 plane of symmetries. Out of that, 13 axes of symmetries. Out of that, 6 are triad, 4 triad, and 3 tetrads. And total element of symmetry the cube has 23. Law of rational indices. Of rational indices, called second law of crystallography, proposed by R.J. Hughes. In order to study the crystal, it must be find out 3 distances along x, y, z where the plane cuts. And he made one statement that it is possible to choose along the 3 coordinate axis unit distances A, B, C such that the ratio of 3 intercepts of any plane in a crystal is given by MA as to NB as to PC. M, N, P will characterize the plane. M and P are coefficients of ABC called wedge indices. But we can't use wedge indices. Wedge indices are inconvenient. It contains infinity and 0. If the plane is parallel to the axis, so that plane is shown as a mirror indices of planes. Mirror wedge indices are replaced by Miller indices. Reciprocal of wedge indices are Miller indices, which indicate particular plane present in the crystal. And interplanar distance is given by DHKL is equal to A upon under root of H square plus K square plus L square. H is HKL are Miller indices. A is edge length of the cube and D is interplanar distance. In order to calculate Miller indices, we have to follow certain rules. Find the intercepts along the axis. Take reciprocals, convert it into suitable smallest integer, and write it should be written in parentheses of the bracket 3 to 6. It should be written in parentheses of the bracket. So consider first of all bigger plane. So this one, it cuts at x-axis at 3, y-axis at 2, and z-axis at 1, and therefore its intercept ratios will be 2, 3, 1. And when we take reciprocal of that, you will get 1 upon 2. Reciprocal of 2 is 1 upon 2. Reciprocal of 3 is 1 upon 3. And reciprocal of 1 is 1 upon 1. And convert to the smallest suitable number by multiplying 6. So you will get 3 to 6. And that should be written as 3 to 6 are Miller indices. Means 3 to 6 plane is present in the crystal. So second example, another crystallographic plane. So this will cuts at A 1 by 2 along y-axis, B A, consider a crystallographic plane. So this will cuts at x-axis at A having distance 1 upon 2, at y-axis at B having intercepts 1, and at C along z-axis having intercept 3 by 4. When we take the ratio of these two, so you will get 1 upon 1 upon 2, 1 upon 1, 1 upon 3 upon 4. So you will get 2, 1, 4 upon 3. So now it becomes again fractional. So we have to convert it into whole number by multiplying smallest suitable number 3. So you will get 6, 3, 4 plane is present in the crystal. So next example is, if we consider this plane, so this plane cuts along x-axis at A, 1, intercept is 1, y-axis at B, intercept is 1, and at C, so this plane is parallel to the z-axis, therefore it should be written as infinity. When we take the reciprocal of this one, 1 upon 1, 1 upon 1, 1 upon infinity, 1, 1, 0, and so that will be written as 1, 1, 0 plane is present in the crystal. So these are the Miller indices. If we consider this plane, so in this plane, so it cuts at along x-axis at A whose distance is 1 by 2 along y-axis at B, whose distance is infinity along z-axis at C, whose distance can be written again infinity because along the b-axis and along the y-axis and along the z-axis this plane is parallel, therefore written as infinite. So 1 upon 1 upon 2, 1 upon infinity, 1 upon infinity. Remember that 1 upon infinity is 0, 1 upon infinity is 0, and 2 upon 1 upon 2 is 2. Therefore, we can write mirror indices as 1, 2, 0. Thank you.